We have looked at position versus time graphs, and next we looked at velocity versus time graphs. So next we're going to want to look at acceleration versus time graphs. So the first thing you want to do is you want to check and see what kind of graph you're looking at. So if we look up top here, so we have a letter D or sometimes a letter X. So that's telling us that this is a position versus time graph. We've got the letter V here, so that's going to tell us that we're looking at a velocity versus time graph. And then the letter A here is going to tell us that we are looking at an acceleration versus time graph. So as we analyze this series of graphs that describes the motion of our particle, we see in the position of the graph, in the position graph here, so our object starts at the origin here. And also the slope looks like it is just about 0, so that means that it's starting out at rest. The position graph curves up, so we've got a slope that's increasing in value, so that's telling us that the object is moving faster and faster to the right. So as we read that, I think we get a decent idea of what's going on in our situation. So now we can check on the velocity graph, and the velocity graph tells us that here we've got the velocity is 0 at the beginning of the graph, right? The object is at rest, and then as the object speeds up, so then the velocity is linearly increasing. So notice that the velocity here is increasing, so that means a change in velocity is telling us that there is an acceleration. So what that means is that if we look at the slope here, so the rise over run of our velocity graph, so the rise is going to be the change in the velocity, and then the run is the change in the time. So that means that the slope of the velocity graph is going to be the acceleration. So that means that this has a positive slope. So that means during this entire time we have a positive acceleration. So yeah, so the idea is that our object started at rest, the object sped up to the right, and because of that happened because it has a positive acceleration this entire time. So to think about this, the position graph, what it's really telling us is, it's telling us if we're on the right or the left, right? So if we're a positive value of the position graph, we're on the right side. If we're on the negative position graph, then that tells me that we're on the left side. For the velocity, this tells you whether the object is moving to the right. So if the velocity is positive, you're moving to the right, and if the velocity is negative, then you're moving to the left. The acceleration tells us how the velocity is changing. So that means that the velocity is changing to the right if it is positive, and if it's negative, then the velocity is changing to the left. So yeah, we have to be careful because the positive acceleration doesn't tell us what the velocity is, it just tells us that the value of the velocity is increasing. So yeah, so if the acceleration is positive, that means that the value of the velocity is getting larger or more positive. So let's say if the velocity is positive, so if our velocity is 5 meters per second, so if we have a positive acceleration, it's going to be a larger number. So it's going to be 6, 7, 8 meters per second as time goes on. And if the velocity is negative, let's say it's negative 5 meters per second, then a positive acceleration means that the new velocity will be, minus 4, minus 3, minus 2. So both of these cases, we've got a line with a positive slope, but if we're in the negative territory, then that means we're slowing down, we're moving to the left and slowing down, and if we're in the positive territory, then we're moving to the right and we are speeding up. So yes, the acceleration tells us how the velocity is changing. If it's positive, the velocity is changing to the right, and if the acceleration is negative, the velocity changes to the left. So whether you're speeding up or slowing down depends on which way you are going. So yeah, so another thing I want to point out here, is this area under the curve. So we talked a bit about the area under the curve of the velocity. So if we have the area under the curve in the velocity graph, this is the change in position. Now if we look at the area under the graph in our acceleration graph, that is telling us the change in the velocity, right? So the idea is that this becomes the basically the time here, and then this is the acceleration. So that means if we do the acceleration times the time, that becomes the change in velocity. So this is like what we did with velocity, where the area under this graph corresponded to the displacement. Here, the area under the acceleration is equal to the change in velocity. Again, you don't know the initial velocity, you just know by how much it changes. Okay, so so now we've set up a fair number of questions that we can ask you about explaining motion using the position, velocity, and acceleration graphs. So here's the first one we have for you with acceleration. So basically we're told that the acceleration is positive for a bit. So positive acceleration, then it goes to 0, then it is positive again. So what does that mean? Well, we don't know the initial velocity, but acceleration tells us the change in the velocity. So a positive acceleration means that the velocity graph must go up, then the acceleration is 0, so then the velocity graph goes flat, and then the acceleration is positive again, so that means that the velocity must go up again. So this might go against your intuition, but remember, if you're moving to the left, a positive acceleration slows you down, so your graph is going to go something like this, and if you're moving to the right, and you have positive acceleration, then your velocity is going to go up, and you're going to speed up here. So I think this one shouldn't give you too much trouble. Okay, so So that's your last classwork question. Remember, you do have a homework due on Tuesday at 10 o'clock, and this is the homework. It's been pushed back due to drop ad. Also, the intro labs are running this week, so please don't miss those. So this is a good place to stop. I think we'll do a bit more with graphs next time and do some problem solving with kinematic equations. All right, good luck and take care of yourselves.